Hello everyone, and welcome to Jam Academy. In this example, we have a box of mass m sliding on a rough horizontal surface with a speed v and eventually comes to rest due to friction acting between the box and the surface. Now, the coefficient of kinetic friction between the box and the surface is mu. We've been asked to determine the average power produced by friction as the box stops. The average power produced by friction. Now, I would love to start this problem by illustrating the forces acting on the box. The box is already sliding forward and is gradually slowing down to rest. So we have the weight of the box acting vertically downwards, mg. There is the normal force that acts perpendicular to the surface, n, and obviously there is friction that acts in the opposite direction of motion. It's kinetic friction. Now there is no force forward. Now the box gradually comes to a stop. What that means is that V final is equal to 0. V initial is equal to V. Now, what we know is that V final is equal to V initial plus AT. Now, because the box is decelerating to rest, the acceleration is negative, and all of this is equal to 0, which means that the time it takes for the box to come to rest will be equal to V divided by the acceleration A. Now, just keep this in mind. We may or may not use this, but I guarantee that we will use this. Now, there are two ways that we can calculate the average power produced by friction. We can use the fact that the power generated by a force is equal to the component of that force parallel to the direction of motion multiplied by the velocity, the average velocity of that object. Or we can use the fact that power is the rate at which energy is transferred. So I'm going to use both methods just to illustrate how you can do this. So let's get started. First of all, we know that the sum of forces along the y direction, this is equal to n minus mg. All of this is equal to 0, which means that n is equal to mg. Now, the sum of forces along the x direction, this is equal to 0 because there is no force forward, minus f sub k. All of this will be equal to ma. Remember, it's equal to ma because the system is decelerating. What this means is that negative mu mg will be equal to ma. This cancels off and the acceleration is equal to negative mu g. This defines the acceleration of the box. We may or may not use this, but I guarantee that we will use this. Now, the average power produced by friction will be equal to the friction force multiplied by V average. Multiplied by V average. And the friction force is just going to be equal to mu mg multiplied by V average. So the question is, what is the average speed? What is the average speed? That is a good question for you to think about. Remember, the initial speed is V and the final speed is 0. This means that V average is equal to V plus 0 divided by 2. This is just going to be equal to V divided by 2. Hence, the average power will be equal to 1/2 mu mg V. This defines the average power produced by friction as the box eventually comes to a stop. This is method 1. Now, the second method that we can use we can use the fact that the average power P is just equal to the rate at which the energy is transferred, all divided by T. Now, the energy transferred here is the change in kinetic energy. Is the change in kinetic energy. That means that this is equal to the kinetic energy final minus the kinetic energy initial, all divided by T. Now, the kinetic energy final is 0. So what is the kinetic energy initial? Ke initial is equal to 1/2 mv squared. But what is T? T, from our calculations above, is equal to V divided by A, which is equal to V divided by negative mu G. So we know the expression for T. So this would imply that P, which is the average power, is equal to negative 1/2 mv squared, all divided by T, which is V bracket, which is negative V bracket mu G. Now we can simplify this clearly. The negatives will clearly cancel. This V will take off one of these V, and we will be left with P equal to 1/2 mu mgv, which is the same as our answer before, which is literally the same as our answer before. Now, this is a very beautiful problem, and I will recommend that you actually watch this problem over and over again. If you still have any questions after watching this brief lesson, I will recommend that you should ask your question in the discussion forum below, and we will be able to actually help you. Thank you so much, and remain blessed. Bye-bye.